60 to 70% of power we consume comes from thermal power, burning fossil fuel, that causes 40% of global pollution, and consume our limited fossil fuel resource. To offset carbon pollution we need to find an efficient renewable energy source that is available 24/7. Solar power is available just 5 to 6 hours peak in a day. Oceans cover 70% of Earth and marine power is enormous, its power flux density is around 300 times more than wind. India has around 7,516 kilometers of coastal belt, good scope for marine power.
Ocean wave energy is most reliable renewable energy, which is also constituent around the clock.
California at Berkeley's Reza Alam put it like this: every square meter of solar panel receives 0.2 to 0.3 kilowatts of solar energy, and every square meter of wind tower absorbs 2 to 3 kilowatts, and every meter of California coast receives 30 kilowatts of wave energy. Second, water has more mass than air. Because potential energy is calculated using mass and velocity, it has the potential to transfer more energy. That means there's a lot more potential energy in the sea available for capture. Now, a lot like solar, the trick is to efficiently and effectively convert all that wave energy into usable electricity. Now, at the heart of this problem is developing an optimized wave energy converter, or WEC, that can generate electricity while surviving the harsh conditions of the ocean.
Purelectron wave engine is a low-cost, innovative, marine wave energy converter device for consistent and optimal electric power output. It can generate consistent electric power in spite of wave irregularities and low-height wave.
Nearshore model of wave engine is low-cost, modular, can efficiently capture kinetic energy from heave, sway or pitch motion of waves. It uses resonance and multi-point power capture with potential energy storage mechanism, which provides continuous torque output during the longer wave period intervals, thus, power output is not interrupted.
The device converts relative motion of overpassing waves into power.
Our output wave DC power is transmitted via single cable to onshore substation to be sold to power grid. Or the output wave power can be used by coastal local industries. Wave power desalination plants can produce drinking water from salty seawater, and from output brine water we can produce clean hydrogen with electrolysis using wave energy.
Major key advantage of this design is from everything being above the water, makes it very long-lasting and cost-effective to maintain. We are certain that energy conversion systems for ocean surface waves will make the renewable energy more reliable to harvest.
A minimum capacity factor of 40% all on its own, but this can be boosted to over 80% if it's co-located and combined with offshore wind. Wind and waves actually do form a dynamic duo. Remember how waves tend to be strongest in the winter months? Well, wind tends to surge in the summer. Now, when comparing the cost and lifetime power production for generators, we tend to use levelized cost of energy, or LCOE. It's a calculation that tries to holistically measure how much power a given project will produce over its lifetime against how much it will cost over the same period of time. Both wave power and offshore wind tend to have high relative LCOEs for similar reasons, but co-locating these green energy devices can really help bring down the number. They can share electrical export infrastructure. 2 devices in one space saves real estate costs, and it makes maintenance easier and cheaper to perform since they're right there together. A 2019 study from NREL suggested that if all goes well, the LCOE of wave energy converters could be as low as 30 cents by 2033, which would be about $300 per megawatt hour. Now, LCOE, of course, varies a lot from site to site.
Carbon emitters are the industries burning fossil fuels, producing tons of CO2. They have to offset the carbon via purchasing or generating carbon offsets, via financing clean renewable projects. They can go for ocean wave power project financing that will benefit them with good profits, as being a cheaper renewable energy generation option than solar or wind power in megawatt scale. Net carbon footprint offset will provide them carbon credit to meet government compliance policy goals.
Purelectron wave power will be cheaper than solar or wind power in megawatt scale. Initial cost per megawatt around 3.65 crore Indian rupees, afterwards cost can be 2 Cr per megawatt. One-time investment, 20 years of profit. Break even within 5 years. It can act as breakwater, can offset 950 gram of CO2 per kilowatt generation. Buoy can be made of metal and plastic waste. Environmentally safe. Energy park can be created after seabed lease. Hydrogen fuel, desalination plant options. Guaranteed profit return.